Okay, the next thing we're going to look at is going to be the jump from object. Our jump from object function is basically going to allow the character to jump against a object with a tag name wall. And if the wall itself, we're gonna basically check for making sure the wall is pretty much straight up and down. If the wall is straight up and down, it'll allow the player to actually jump from that object. Let's go ahead and place inside of Unity. Let's place a cube inside the hierarchy. And the cube, let's go ahead and just make the scale of it. We'll take the scale to about a 8. Actually, here we'll do 8 by 8 on the X, on the Y, and the Z for this one, and a 1 for the X. Alright, so we'll give the player a wall that he can jump against. The tag name, if you click on the drop down, you should see one called wall. Right, so in order for the player to jump against this object, it has to be sure that it's actually labeled wall. Now, say for instance that we have this, what we're going to basically be doing is checking for whether or not the player is hitting it. What we've done before, we've actually been using the trigger enter option over here. This time around, we're going to use the on-controller collider hit. The collider hit is basically going to be checking a ray sent out from the direction of the hit. The object, this character right here, has, just like a box, it's going to have 6 sides. So if the object is being, for instance, touching the ground, we can play this real fast just to show you. It's currently set on debug draw ray. So if you notice, you can either have the gizmo button checked in the game view or in the scene view. You'll notice that the character actually has a ray drawing down. If I jump, you'll notice that the ray actually disappears. Now the reason the ray disappears is that none of the sides are actually being hit. Okay, so if you jump, there's no ray. When it hits, there's a ray. If I go over to against the wall, so for instance I move against the wall, notice that now my point, when I move against the wall, points towards it. It also points down because there's 2 sides being hit on this one. Okay, so that's basically all we're doing. We're going to check against it, and then by checking against it, we can do similar to like the trigger enter. We can take the information of the object being hit, collided against, and we can determine whether or not it's something that we can use. And for instance, ours is going to be the wall, so we can check if it's going to be the wall object. Alright, so let's go ahead and get started inside the on-controller collider hit. Inside of it, let's go ahead and use some of the basic setups. The one that we're going to use for this is going to be checking for the hit collider. Okay, so the hit collider means that the object that the player is pushing against or hitting against. We want to find out that if the hit collider tag name is going to be equal to the tag name of the object, which is wall. What we want to do for that one, we're actually going to use a let me click on it here. We're actually going to use a defined variable inside of our controller system, and this one is going to be called jump from object tag wall. Alright, so if it is equal to the jump from object tag wall, then we'll actually go for that. So jump from object tag, there we go, I think it's right, jump from object tag. So if it is actually equal to that one, then we're going to make a statement that simply just turns on jump. It's going to be a jumpable object, and we'll set it to true. So if player actually hits this and it becomes a jumpable object, we'll set that to true, which then allows us to basically use our jump from object and enable it, and then have the character jump against the wall, check for the normalized direction against the wall, and throw the character off the opposite way. Alright, for this part, let's go ahead and finish off one more thing on the jump from wall. We want to actually capture the hit normal direction. So the hit direction meaning this direction. If I hit this wall, the normal direction of this one is pointing 90 degrees this direction. Okay, so we want to store that information so that we can use it when we're moving the player. This one, we're just going to store it inside a variable called object jump contact normal. And this would be equal to the hit normal direction. Alright. And let's go ahead and define these, comment them since we're down here. So again, this is just if the hit tag is equal to the wall tag. And if it is, then let's just set jump object to true. And the last thing is we'll store the jump contact normal direction. Alright. So with this one, this means that when we actually go against an object with that label that is wall, it should actually give us some information about it. What we could do, let's just do one more thing here. How about we just say print? That way if we actually hit it, we'll say that the, here we go, we'll place this up in our jump from object. That's what we'll do. So let's put this up in the jump from object. So up in the jump from object, just like we've done before, we're going to do a can jump from object. So we'll do a quick check. It's going to be can jump from object, and this one you should notice it's a Boolean statement based on this one up from here. Jump. Let's see, can jump from object. All right. So if the player can jump from the object, and if based on down here, we were using the word, let's see, jumpable object. So if player can jump from the object is true, and if the jumpable object is true, then let's just do a quick print statement. And there we go. So we're just going to say that if the player actually comes up against the wall, we'll actually print that the object is jumpable. So the player moves up against the wall, and once we have that one, object is true. Now, the reason why, if you notice, the reason why it's not actually playing directly up against it, there we go. You have to make sure you're moving up against the wall, otherwise the ray being pushed against it doesn't actually connect. All right. So now, if we actually have the jumpable object is true, the next thing we need to do is kind of set up another rule for ourselves. Is do we want the object? Do we want the player to be able to jump directly from the ground for a jumpable object, or do you want the player to be that it has to be in the air to jump from an object? This one is going to kind of be up to you. You can actually do another check for it and have something inside the inspector to say from ground or from air for the jumping. I'm going to go ahead and just set it as defined that the player has to be off the ground in order to do this. So up here we'll just say if the function is grounded is false, and jumpable object is true. And then we need one other element here, is that if we have the player in the air and we have jumpable object is true, meaning his ray is connected to the collider, it says it is a jumpable object. We need something else in order to be able to jump against it. Now we could do it where it's just simply you don't even have to push a button. If you just simply collide against something, it forces you out the other way. So that is an option that you could do right here at this time. What we want to do though is set it so that you have to make a some type of input. So we're just going to say get button down. And the get button down, just to keep it consistent with the other jump statements and types, we'll just continue to use the jump option for it for the get button down. Alright. So, let's see, we already have those in there. So if we have the check on this, that means that now the player has to be in the air, has to be hitting the wall, and has to be pushing the jump button. Alright, so let's go ahead and try that one. Alright, so I shouldn't get anything. So notice I don't get anything here. Now if I jump, I still don't get anything. Now if I jump and then push the jump button, then I actually get a contact. So I pushed the jump button while I was in the air, and I got jumpable object is true. Alright, so that means that we've kind of set up a nice little system there that the player does have to actually be in the air, and then also has to be able to push the jump button. So instead of printing that it actually is connected, let's go ahead and set up the functionality for it. First thing that we want to do, let's go ahead and set our jumpable object to false. That way, it's just going to run one time through. For the collision side of it, let's say that if the player actually hits against the wall, let's turn off the other current jumpings that we have. This part of it, this is more of an element that once you do it one time through, you'll notice that you have to start checking against other objects, for instance, like our other jumps, to make sure that we're not messing anything up on that side. So what we're going to do is check to find out if the object has collided with any of the sides. So we'll say if collision flags is equal to the collision flags and we're checking to see whether or not we've collided with sides. So we're just going to say collided sides. Now if we've collided with any of the sides, then we want to go ahead and just turn off. So all we're going to do is just turn off our isJumping modes. So we're going to say isJumping_1, and we're going to leave 1 to true. That way when we fall back on the ground, we'll go ahead and have 1 reset so that you can go ahead and jump again. But the jump 2 and jump 3, we'll set those to false. Alright, because you may be jumping in air, and when you hit against the side of a wall, you could be on jump 2. And we don't want to have the character land back on the ground and be ready for jump 3. We just want to reset everything back to a jump 1 state. Alright, so go ahead and set this one to true. And we'll copy these lines. Set these to false. And set these to 2 and 3. Alright, and you can also set, we're not going to put this one in, but if you wanted, just like we've done before, you can set a get a current time, so that when the player actually hits the side, you can say get current time, and then you can do a delay for the jump. You can say if current time. Alright, so the basic idea, though, again, that would be a way to set up a delay between your jumps so that you can't jump too often. For this one though, so for instance we've set this, we've decided that when the player actually does hit a side, we'll reset his basic jumps so that he doesn't jump on the ground and do another jump, and that would just be a rule. You could actually delete these and allow him to still be able to jump in the air that way. For the next part, what we want to do is check whether or not the wall itself is actually 90 degrees up and down. This could be something where you have a you could actually provide an option inside the inspector, and that way your player could jump against say a 45-degree angle and still make his way off of that wall as a jump state. For this one though, let's I'll just go ahead and set it so that it's close to a straight up and down. So what we want to do, when you rotate the a wall piece like this, the wall itself, if I go left, right, I get a positive and a negative on rotation. We want to make sure that whether it's a positive or a negative on the rotation, is that it's still just simply based off of the number value from 0. And to get that, you want to get the absolute value of it. And absolute value is just going to be a ABS for it. So what we can do inside of here is we can actually check on, we'll use our, and the mathf function is going to be ABS, and we're going to take our objects hit normal direction, so that one right there. Alright, so we're going to say object jump contact normal, and it's going to be the Y. We're actually going for the up and down. We want to make sure that's going to be straight up and down on it. So if the absolute value of Y up and down is less than 0.2, we could say 0.1 or even 0. But if the user is just slightly off from it, or the player's if it's just slightly tilted, we don't want to penalize them too much for being not completely exact. You could go pretty close to, though, if you wanted. Alright, so we have once we have actual contact with the wall, and we could do a quick check, we could say wall is just straight, and go ahead and save this out. So what should happen is we get an error right there. Let's double check. We have one on 453. Let's see, that one might actually be, I think we've got a missing eye right there. There we go. Alright. Okay, so inside of here, if we play, the player again, when you are jumping in the air, if I jump in the air and then I push the jump button, it's going to have Wallace straight. That means that I actually made it all the way through here. This statement is true. Now, just as a quick check, if I was to take this wall and tilt it, okay, so we're tilting it at 9.0, which is way past the 0.2 angle that we're looking for. Now if I go against the wall, let's go ahead and clear this so you can see it. If I jump and then jump again, notice that I actually don't get any information about this being a jumpable wall because the angle's too much. The player can basically just walk up this wall. Alright? Okay, so this kind of gives us an idea that an indication at least that the wall does have to be straight. And again, that's one of those just rules that you could set. You could have it so that the player could jump off of anything, and you don't have to check against the angle itself. You could just simply say that if the player is in the air and he's jumping off of any object, we could bypass this statement right here, this check, and just say have the player jump off of that normal. So if you're looking for a game that's like really interactive against any object, you may want to just comment this out and then just have it go through this next set of statements. So let's go ahead and take the print option off right here. Let's go ahead and assign an animation to it. So we're just going to say animation play. Instead of being the crossfade, we'll go ahead and just take complete control of the animation immediately and just say it's going to play. And the animation that we want to play is going to be our jump from object animation, which should be, let's find the right name for it. Jump from object. Alright. So ANI, let's make sure we got the right one down here. So animation jump from object. Alright, and we'll get the name for that one. So animation jump from object, this means that when the player does go through there and hit the right thing, he'll have the animation playing. And we'll go ahead and provide the message for it. This is just going to be animation state, and it is jump from object. Alright. Now, what happens next? If we were to, even when we do this, the player doesn't go anywhere. He hits the wall, and he'll play the animation, but he just stays there. Well, we want to make sure that the player actually changes direction and moves outward again from the wall, so that he actually has a jump from a wall kind of look to him. The setup for this one is basically going to be taking the normal direction, normalizing it so that it faces the opposite direction, and then forcing it out with a speed and a velocity. Alright, so what we want to do is take our object jump from contact normal. So object jump contact normal, and we're taking the Y up and down on it. We're going to go ahead and set this to 0. And we're just going to reset it so it's at 0. We're going to take the move direction. So if you remember move direction, let's go back up here so you can see this one. The move direction is the player forward direction. Alright, so we're taking the move direction of the player now. And the move direction itself, we want to actually make it equal to the object jump contact normal. Normal. And notice we're actually storing the full vector 3 inside of this, so we're actually taking the x, y, and z from it. The object jump contact normal, what we want to do with it is normalize it. Now if we normalize it, notice we have two options for normalize. We have a function call we can make, but we also just have a regular variable for the vector 3. This is going to get the magnitude of 1, so basically it's going to return, we're going to get a value of basically 0 to 1, and it's going to be the normal direction of the object that we hit. Okay, so that means that if we hit this object right here, if this side is facing 1, or if it's facing -1, then it's going to be that direction that it goes. Alright, so we have normalized right there. If we want to find out, what's actually being done on that part, let's go ahead and just print this one. Let's print the jump object. So object jump contact normal, and we'll print the normalize. Alright. So just so you can see what's happening right here, when the player jumps against the wall, we're going to get an XYZ, just a vector 3. And do you see how it printed at this point right here? It printed 1, 0, 0, 1. Now, notice for a moment though, I take my character and I jump from this side. So if we take the player and we jump from this wall right here, notice the XYZ on the Z-axis, we actually have the -1 pointing here. Now, that means, if you can kind of imagine here for a moment, we'll say that the other side of the X. So I'm on the back side of the wall. If I jump against it, what value should I get? You should have guessed it would be a -1 value. We had the +1 value here, and we have -1 value here. Alright, so this is giving us that direction. Alright, now notice I've already set my move direction, the player of my character. I've set that direction to equal the normalized value of the object that we just hit. So if you notice, let's move the character back around here. When I jump against the wall, it automatically moves the character the other direction. So it's flipping the character the other way. So for instance, do you see how he actually flipped him that direction? Alright, now we have a basic movement right here, but you see how the player just kind of falls from the jump? He doesn't actually go up. We need to actually have a little bit more control, a little bit more speed to the player. That way he can actually have some movement. So let's go ahead and get out of the game mode. Back inside of here, the speed itself, we'll go ahead and delete that part here. The player move speed. Remember, we've been using the move speed to actually move the player around, increases speed. For the move speed on this one, let's go ahead and set one. There is a speed for jump from object. So speed, jump from object. Alright, so our move speed is going to actually equal the speed jump from object. Now something that you want to do is, once you've set this in, this is going to force the character back the other direction faster, but there's still going to be, let's go ahead and show you on this, there's still going to be a slight drop on the character, and see, he goes further out, which is great. He has a good speed, but in terms of up and down, he's still falling. Now, if we were trying to use this where we put a wall, say for instance, we put another wall piece right here, and we were trying to make him bounce back and forth and climb up the wall, he's not going to be able to do that because his vertical speed isn't actually going up. The gravity's forcing him down too much. So what we want to do is actually increase the vertical speed. That way he'll go upwards on it. Alright, so the vertical speed, now this is a new one. We haven't used this one yet. The vertical speed is actually getting direct access to the character's final vertical up and down speed. That means that we're getting this based off of our in-air vertical.y on the vector 3, and we're getting it based on the gravity. Okay, so we're going to actually just do a one statement over. We're just simply going to say vertical speed is going to equal 0.02. And this one you could actually set to, I'm going to keep it inside the code side, but you could set this into the inspector and allow the player to have an up and down control for how high up or down the player is going to be going based off the jump. The other part that we want to do with this is we want to go ahead and do the in-air velocity. And the in-air velocity, the jump height that we're going for, we want to say that the character's height is going to be jump from object. Alright. So the height of it is the jump from object, and we have that one, jump from object, right here. And we are setting the vertical speed just a hair up so that it's going to be pushing above the gravity level. Now, based on those two things, If we save it and go back into Unity, when the player goes against the wall, you'll notice that now when the player hits it, he actually jumps upward. Alright. So let's go a little more sideways so you can see this. So this means that if he goes slightly upward, and here, just to show you what could happen, say for instance I set this to we'll say to a 2-point value. If we were to set vertical speed a little bit higher, notice how much higher he goes upwards. We don't really want it to go that high up. You know, if you want to, you could set, again, like I said, you could set a value there. But we're going to make sure that the player just goes a little bit higher. What this will allow the player to do, though, is we can make a copy of this. Just Control D to make a copy. I can set another wall piece on this side, and since it's labeled with a tag name wall, as long as I'm in the air and when I push the jump button again, he can actually do his next jump. Alright, so, and you notice how the moment he collides, the ray collider, the ray being sent out is showing he is collided with it. So we could continue jumping back and forth. This is a kind of a nice jump height. It's just slightly higher than where he started, so he could do some serious wall climbing and actually go scale his way up between 2 points. Alright. This gives us pretty much what we need on this side. The one thing that we want to do one last check on is that if the player is grounded, if he's not grounded, if he can jump, he meets all the requirements going down. But when it gets to the wall piece here, let's go ahead and do one last part. This is just a check to say that if the player does hit a wall, but it's not equal to, it's not less than 0.2, so basically saying it's not straight up and down. Let's double check on the speed and just set it down to 0. We don't really want the player jumping off from there. We just want it to feel like he jumps against an object, and he's just going to move downward. He's not going to do anything else from there. Alright. So that actually finishes up our jump from object. We'll spend just a little bit of time here and do some commenting. Alright, so the comments on the side, just be sure to take a moment, pause, and just write these down. And remember again, just a quick run through. Your player, when he hits the on controller collider hit, it sends a ray out, finds the collision, checks for the hit. The hit that we're looking for is the tag name from the object. Up inside of here, we're using the tag name, the jump from object tag right here, so that we can use it up inside of here. We check for the hit direction, the normal of it, and if it's actually set to less than, if it's up and down straight, then we play an animation, and then we turn the character around the opposite direction with the move direction, and we force the character outward with a speed. We add an additional vertical speed just in case, so that the player will stay up in the air a little bit longer, and we send the player out with a little bit more force. So we have the speed, the height, actually this would be, the height right here. Alright, so that's going to be the basic setup for you for your jump from object.